Look at these blocks. I've put them in order from biggest to smallest. But could I put them in a different order? Of course. I could put them in order based on color, like the rainbow, orange, yellow, green, blue, violet, or purple. Or I could put them in a random order. They're the same blocks, just in a different order. What happened though? Did the overall shape stay the same? No, it didn't. It changed. When I messed with the order, I changed the final result. Look at this mathematical expression. It's got numbers and operations. How could you make it simpler? In what order would you add and multiply everything? Could you do it in whatever order you want? Maybe. You could go from left to right or from right to left. You could start in the middle and go towards the end. You could do it however you want. Just like the blocks, you could put it in whatever order you want. But would you get the same number every time? Were the blocks in the same shape when we changed their order? No, they changed. And that's because order affects it. The same is true with mathematical expressions. Order affects value. Now, the reason we use this particular order is not something we have time or space for to talk about in this class, but there are two things you need to know. One, the order does matter, and two, what that order is. And that's what we're going to talk about today. The order in which you perform operations can affect the value of an expression. So if order is important, which is the right way? To avoid any confusion with what order expressions are simplified in, we have an agreed upon order of operations. First, let's define what it means to simplify. To simplify an expression, you use the order of operations to replace the expression with the simplest value. We see simple inside of that word simplify, and so that's what it means. We're looking for what's the simplest form of this number or of this expression if it gets down to a single number. Sometimes it's not just a single number, but for the ones we're working with right now, it'll just get down to a single number, and that's what it means to simplify. You're probably familiar with the order of operations. Parentheses or any other grouping symbols, exponents, multiplication and division, addition and subtraction. Some people use the phrase Pemdas in order to remember it. Let's explain a few things about that though. P stands for parentheses. This includes all grouping symbols, including brackets. Grouping symbols such as parentheses and brackets indicate order. We work from left to right, and we follow the order of operations inside of the grouping symbols. We do what's inside of the grouping symbols, parentheses or brackets, first. And when we're inside of them, we work the normal order of operations. Exponents. These are powers that a base is raised to, like 2 to the third power or 5 to the second power. When the exponent is on a parentheses, we do what's inside of the parentheses, and then we raise it to that exponent power. Multiplication and division. Once you've done everything in parentheses and with exponents, then you'll start to multiply and divide, and you'll move from left to right with multiplication and division. What I mean by moving from left to right with multiplication and division is that multiplication and division are of the same rank in the order of operations. So when you're down to the two of them, it's not that you do multiplication first, we just say it first. You actually would move from left to right in this expression. So I would do 15 divided by 3 is 5, and then I would times by 4 to give me 20. Okay? So that's what we mean by left to right. Lastly is addition and subtraction. Once you've done everything else and you're left with just addition and subtraction, then you'll add and subtract from left to right. Just like with multiplication and division, addition and subtraction are of the same rank. So when we get down to just those two, it's not that we move addition and then subtraction, it's that we move from left to right. So in this expression, I would do 5 minus 3 first, and then add the other two. We will also be comparing expressions in this lesson, and you're probably familiar with these symbols. This is greater than. This is less than. And this is equal to. We'll use these symbols to help us compare different values in different expressions. Some people like to think about greater than and less than as alligator mouth, and the alligator eats the larger number. Instead of chaos, the order of operation gives us structure for evaluating and solving our math problems. When we approach an expression, the order of operation tells us what we do first. It's a guide for how we approach problems and expressions. So why don't you jump over to lesson 1.2 examples to see how this is done.